So good afternoon, everyone. Yesterday, I think we have started a new chapter that was moving charges and magnetism. And we have discussed regarding Biot-Savart law. Then we have started Ampere's law, but at that time there was a power cut, so we were unable to continue the class. So today, let us start once again. I will be just writing the formula for Biot-Savart law. Then I think we have did one application based on Biot-Savart law. After that, I have given one formula for Ampere's law, and we were doing the application based on that Ampere's law. So let us see what was the thing that we have discussed yesterday from moving charges and magnetism. We have discussed one formula that was dB is equals to mu naught divided by 4 pi into IDL sine theta divided by r square. This was the formula that we have derived in yesterday's class. And this formula was known as what? It was known as Biot-Savart law. Why we were using this formula? We were using this formula to determine the magnitude of magnetic field created due to a current carrying wire. So similarly, yesterday we have discussed regarding Ampere's law also. Ampere's law. And what was the formula that I have given for the Ampere's law? It was closed integral B bar dot dl bar that is equals to mu naught times the net current enclosed in that closed surface. So this was the formula that we have discussed yesterday. And what was the statement for this? The line integral of magnetic field around a closed surface, is equals to what is that? Mu naught times the net current enclosed. So this was the statement we have discussed regarding Ampere's law, and we were doing the application based on this Ampere's law. So let us continue the yesterday's class. See here, what was the application we were trying to do? Magnetic field induction, due to a straight current carrying conductor. So let us consider a straight current carrying conductor. So this is a straight conductor through which some current I is flowing. Through this conductor, some current I is flowing. And we know that according to Eirsted, what he said, whenever there is a current flowing through a conductor, around that current carrying conductor, what will be created? A magnetic field will be created. Yesterday we have discussed one law that was called as right hand thumb rule. Yesterday we said that whenever a current is flowing through a circular coil, then the thumb represents the direction of magnetic field. Now see here, the current is flowing through this wire. So we should represent thumb with respect to the current. See here, thumb represents the direction of current, then curling of finger represents the direction of magnetic field. If thumb is representing the direction of current, then curling of finger represents the direction of magnetic field. And yesterday further we have discussed that we'll be using cross symbol. When we'll be using the cross symbol? Whenever the magnetic field is going inside. Magnetic field is going inside. And when we will be using the dot symbol, we'll be using the dot symbol whenever magnetic field is coming outside. Outside. Now see here, due to a straight current carrying conductor, the magnetic field will be created around the current carrying conductor, something like this. Something like this. Now, we are supposed to determine the magnetic field induction due to this straight current carrying conductor at this particular point. I am considering the length element here dl. At this particular point, I am considering the length element dl. And what is the distance from the wire to that particular length element? I am considering the distance to be r. I am considering this distance to be what? I am considering the distance to be r. And I have considered a small length element dl. Now see here, thumb represent the direction of magnetic field and curling of fingers represent the direction of, thumb represent the direction of electric current and curling of finger represent the direction of magnetic field. See here, my fingers are going inside. So here the magnetic field will be inside. I am using cross symbol. And here the magnetic field is coming outside. I will be using this symbol. I will be using dot symbol. So here the magnetic field is going inside. Here the magnetic field is coming outside. See here, this is the length element dl and the direction of magnetic field is also in this direction b. So what is the angle between dl and b? What is the angle between dl and b? dl and b. So the angle between dl and b is how much? Theta is equals to 0 degrees. Because this length element dl is in this direction, the magnetic field is also in the same direction. So what is the angle between them? The angle between them is 0 degree. Now let us determine the magnetic field at this particular point. So what is the Ampere's law? We know that Ampere's law is given as closed integral b bar dot dl bar is equals to mu naught times the net current flowing through that enclosed surface. So this is the enclosed surface. Some current I is flowing through it. Due to this current I, what is being created? Some magnetic field will be created around this wire. So we are determining the magnetic field due to this straight current carrying conductor at some distance r. Now see here, magnetic field and dl, both of them are which they are dot product. They are cross product or dot product, they are dot product. If I remove this dot symbol, I should include a trigonometric function. Whether I should include a sine function or cos function, we should include a cos function. So this will become what? Closed integral in place of b bar dot dl bar. I know that what? A bar dot b bar is equals to what? AB cos theta. So the same thing I am writing here. B bar dot dl bar will become what? B into dl cos theta. That is equals to what? Mu naught into I. But what is the angle between dl and b bar? What is the angle between dl and b bar? It is 0 degree. So let us substitute that value. Closed integral b dl cos 0 degree is equals to mu naught into I. Mu naught into what? I. So finally we know that what is the value of cos 0? Cos 0 value is 1. And b is constant or changing, current is constant or varying, current is constant, so b will be constant at one particular distance r. So I can take b outside. And what is the value of cos 0? Cos 0 will become 1. So closed integral dl is equals to, this will become what? Mu naught into I. Mu naught into I. So we know that integration dl will become L. Integration dl will become L is equals to mu naught into I. What is this? The magnetic field is created around this circle, around this straight current carrying wire. In which manner? A circular manner. So what will be the circumference of this circle? Circumference of this circle will become 2 pi r. So our formula will become b into 2 pi r is equals to what I can write? I can write mu naught into I. So what I have considered here? I have considered that integral, closed integral dl is equals to how much? L. And what is this? L is equals to? L is equals to 2 pi r. I have considered this thing. So this will become what? B is equals to mu naught I divided by 2 pi r. So this is our final answer. This is the formula for magnetic field induction due to a straight current carrying conductor or a wire. So what we did, we have considered a straight current carrying conductor and we have represented that thumb represents the direction of electric current and curling of finger represents the direction of magnetic field. Here the magnetic field is going inside and here the magnetic field is coming outside. We are supposed to determine the value of magnetic field induction at one particular distance r from that current carrying conductor. Then what we are supposed to do? We are supposed to solve this using which law? This is Ampere's law. Which law? This is Ampere's law. Ampere's law. So we are done with this Biot-Savart and Ampere's law. We have did the expression for magnetic field using Biot-Savart law and we have did one application based on that. Again, we have derived the formula for Ampere's law. We have discussed the formula for Ampere's law. Again, based on that formula, we did one application. Let us move on to the next topic in the same moving charges and magnetism. So the next topic in moving charges and magnetism is magnetic moment of an revolving electron. Magnetic moment of an revolving electron. This is the next topic that we are going to discuss in moving charges and magnetism. Very easy topic, and I think in the previous examination, main board's examination, you might have got this question. Obtain the expression for magnetic moment of a revolving electron. So very easy answer. See here, what is the formula for magnetic dipole moment? Magnetic dipole moment is given as m is equals to n into I into A. What is that? M is equals to n into I into A. What does n represents here? N represents number of turns. What does I represents? I represents the electric current and A represents the area. So we are supposed to determine the magnetic moment of revolving electron. So let us consider an electron revolving around the nucleus. So here we are having an electron. So in between that we are having a nucleus here at the center. We know that nucleus will be having which type of charge? It will be having positive charge due to protons, and an electron is revolving around this nucleus with some velocity v. This electron is revolving around the nucleus with how much velocity? With some velocity v. With some velocity v. Let the distance from center of the nucleus to this electron is r. The distance of the electron from the center of the nucleus is how much? R. So what we have did? We have taken one electron which is revolving around the nucleus at a distance r with how much velocity? With velocity v. And what we are supposed to determine? We are supposed to determine the magnetic moment of this revolving electron. And what is the formula for magnetic moment? M is equals to NIA. N represents what? Number of turns. I represents the current. A represents what? The area of that particular loop. See here, I have considered only one electron revolving around the nucleus. So what will be the value of n? I can take n is equals to 1. Only one loop is there. Now I am supposed to determine the value of I and A. See here, this is the circular loop. What will be the area of a circular loop? Area of a circular loop will become what? Pi into, how much is the radius? Radius is small r. So this will become what? Pi r square. Pi r square. I came to know number of turns. Only one loop is there because only one electron is revolving around the nucleus. Next, what is this? Electron is revolving in circular manner. So see here, what will be the area of this loop? This is the entire loop. This is the loop. What will be the area of the loop? Area of the loop is nothing but pi r square. Now I am supposed to determine the value of current. What I am supposed to determine? I am supposed to determine the value of current. Let us determine the value of current. So we know that electric current is defined as rate of flow of charge. What is the definition for electric current? Electric current is defined as rate of flow of charge. I am writing charge per unit time. Charge per unit time. Let us determine the time taken by this electron to start from this particular position again to reach this particular position. We know that velocity is defined as what? Distance by time. So I can write time t is equals to, what I can write? I can write time t is equals to distance by velocity. How much distance does this electron is covering? It is covering 2 pi r distance. How much distance? 2 pi r divided by what? V. Let us substitute that value in I. What this equation will become? I is equals to, what is the charge? I am writing in place of Q. Which type of charge is flowing? Electron is flowing. So here I can write E divided by, what is the value of time t I am getting? 2 pi r divided by V. So this will become what? EV divided by 2 pi r. So finally, I can write the final answer here as, what is the value of current I got? I is equals to EV divided by 2 pi r. So the magnetic dipole moment of revolving electron is given as what? M is equals to N I A. So what is the value of N here? Value of N is 1. And what is the value of I we got? EV divided by 2 pi r. And what is the area of this circular loop? I am getting pi r square. This pi and this pi will get cancelled. This r and square will get cancelled. Finally, we will be left with M is equals to EVR divided by 2. So this is the magnetic dipole moment of an revolving electron. Remember this. Very important concept and question for your annual examination, even for supplementary examination. What we did? We have considered an electron revolving around the nucleus with how much velocity? With some velocity v. Next, what we did? We are supposed to determine the magnetic dipole moment of that revolving electron. So what is the formula? M is equals to NIA. What does N represents? N represents number of turns. What does I represents? I represent the electric current which is being generated due to this electron. We know that whenever electric current is flowing, again magnetic field will be created. So that is the reason we are determining the magnetic dipole moment. Next, what is the area? This area of this circular loop is how much? It is pi r square. So we know the definition for the electric current. Electric current is defined as what? Rate of flow of charge. So I have taken charge per unit time. So the time taken by the electron to complete one rotation or one revolution is how much? T is equals to 2 pi r by V. Finally, what I did? I have substituted the value of T in I and I have taken the value of Q as E because electron is revolving around the nucleus. So from here, I got the value of I. What is the value of I got? I is equals to EV divided by 2 pi r. So what I did? I have substituted all the things. I have substituted the value of N as 1. I have substituted the value of I as EV by 2 pi r. I have substituted the value of A as what? Pi r square. After substituting this, I am getting the final answer. Magnetic dipole moment of a revolving electron as M is equals to EVR divided by 2. Further, we can study about this gyromagnetic ratio, but that's not necessary for our main examination. Let us move on to the next topic from moving charges and magnetism. I hope you understood this. So the next important concept from moving charges and magnetism is cyclotron. Cyclotron. So what is this cyclotron? Actually, cyclotron is a device which is used to accelerate the positively charged particles with high energies to with high velocities. What will happen when they are moving with high velocities? The radius will increase. Finally, whenever they are coming outside that particular chamber of cyclotron, they will be colliding with some radioactive nucleus and they will be producing some radioactive substances. So why do we use this device? Cyclotron is a device. What is the cyclotron? It is a device. Why we will be using this device? To accelerate positively charged particles. To accelerate what? Positively charged particles. Positively charged particle. Examples what? Like alpha particle. You can take proton also. Proton. You can take deuteron also, your wish. So what is this cyclotron? Cyclotron is a device which is used to accelerate positively charged particles. So let us see the construction or the components of these cyclotrons. Components of cyclotron. Components of cyclotron. See here. Cyclotron consists of two Ds. something like this. Okay. Cyclotron consists of 2Ds. Something like this. They are called as Ds because they are in the shape of D. So what is the first thing? First component, Ds. So what are Ds and what are they made up of? These are two hollow D-shaped metallic metallic chambers. So what is the first component of this cyclotron? Why we are using cyclotron? Cyclotron is a device which is used to accelerate charged particles. What it consists of? What is the first component we are discussing? We are discussing the first components as Ds. What are Ds? These are nothing but two hollow D-shaped metallic chambers. D-shaped metallic chambers. Okay, let us see what is the second component of this. The second component is vacuum chamber. Vacuum chamber. See here, this entire setup is enclosed in a vacuum chamber such that whatever ions we are taking, that may not collide with the air molecule. So we are taking the entire arrangement inside what? Vacuum chamber. Actually, there will be a magnetic field here. If I want to draw the 3D diagram of this, it will become something like this. The actual diagram for cyclotron will be something like this, but it's not necessary. Just you are supposed to draw a simple diagram only. So here we'll be having two magnetic plates. In between these two magnetic plates, you will be having two Ds, something like this. Here you will be having one D. Here you will be having another D. Here you will be, suppose this is North Pole, this is South Pole. We'll be having magnetic field here. The entire setup will be kept in a vacuum. This is the actual diagram for that cyclotron, but this is not necessary. We'll draw something like this only. So I'm writing here magnetic symbol, something like this. What does this cross symbol represent? Cross symbol represents that magnetic field is inside or outside. It represents that the magnetic field is inside. So this entire setup is kept inside a vacuum chamber. So this entire setup is kept inside what? A vacuum chamber, such that the ion, whichever ion we are taking, that is not colliding with the air molecules. So see here, what is the second component? Second component is vacuum chamber. To minimize the collision of ion with air. Why we are using this vacuum chamber? Whatever ion we are taking, for accelerating it to high energy, in order to minimize those ions collision with the air molecules, we are enclosing the entire setup inside what? A vacuum chamber. Let us see the third component. Third component is high frequency oscillator. High frequency oscillator. Why we will be using high frequency oscillator? Let us understand. It is connected to Ds. It is connected to Ds. So here we are connecting one high frequency oscillator, something like this. This is our high frequency oscillator. What does it do? It will sometimes make this D. Suppose let me write this one as D1 and this is D2 chamber. Sometimes it will be making D2 chamber as positive and it will make D1 as negative. In the next cycle, it will make this one as positive and this one as negative. It will alternate the voltage. It will alternate the polarities of these two Ds. It will become positive, then it will become negative. If this is becoming positive, it will become negative. Who is doing this work? This work is being done by what? High frequency oscillator. This work is done by what? Whom? High frequency oscillator. I hope you understood the meaning of high frequency oscillator. So this high frequency oscillator is connected to what? 2D. And the final component is fourth one, source. What is the fourth thing required? The fourth thing required is what? Source. Source. So we are taking positive ion is placed in between the D's, in between the D's. So I am taking one positive ion source, I am placing that positive ion source somewhere here. Somewhere here. So this is the construction or the components of cyclotron. I will try to explain how a cyclotron works. That's not necessary. For your knowledge, I will be explaining how does the cyclotron work. But for your main examination, these things are enough. What is cyclotron? Cyclotron is a device which is used to accelerate positively charged particles to high energies. And what are the components of cyclotron? The components of cyclotrons are D's, vacuum chamber, high frequency oscillator, and source. Which type of source we'll be considering? We'll be considering the positively charged particle or positive ion as the source. Next, what are the D's? The D's are nothing but two hollow metallic chambers. Then what is the vacuum? Why we are using the vacuum chamber? We are enclosing the entire setup into a vacuum chamber because the ion may collide with the air molecule. In order to minimize that collision, we are taking the entire setup inside a vacuum chamber. And what is the work of high frequency oscillator? This is nothing but an alternating voltage. Sometimes it will change the polarities of D1 and D2 to positive or negative based on that particular experiment. Let me name this one as D1. This is chamber D1 and this is the chamber D2. Now see here, how does a cyclotron works? Everyone carefully see here. Here we are having magnetic field B. What does this cross symbol represent? Cross symbol represents that the magnetic field is going inside. Actually, it is coming from up to down now. So the magnetic field is going inside. So we are using this symbol, we are using cross symbol. Now carefully see here. Assume that this chamber has got negative polarity and this chamber has got positive polarity. This chamber has got negative polarity and this chamber has got positive polarity. And we have taken a positive source of ion. What will happen? Negative and positive charges will attract or repel? Attract. So this positive ion will move towards which chamber? D2. It will move inside D2. And we know that whenever there is a charged particle moving inside a magnetic field, which motion it will make? It will try to make a circular motion. So what will happen? The positive ion source will move towards negative plate, D2 plate. Once it enters this D2 plate, what will be there? Inside the chamber, the magnetic field will be there. So whenever a charge is placed inside the magnetic field, it will start to make a circular motion. So what will happen? It will make a semicircular motion, something like this. Once this positive ion source reaches this region, what will happen next? It will get this oscillator, high frequency oscillator will make this one as positive and this one as negative. What it will do? It will make this one as positive and this one as negative. Due to that, what will happen? It will accelerate towards the D1 region or D1 chamber with high velocity. It will increase its velocity. Once this positive ion reaches this chamber D1, again it will make which motion? A circular motion with little bit more radius because its velocity has been increased. Once again, this particle is reaching at this end. Again, what this oscillator will do? This oscillator will make this D as negative and this D as positive. Again, what will happen? This positive ion will get accelerated towards D2 region. Once this particle enters into D2 region, what will happen? Again, its velocity increases and its radius will also increase. This process goes on. Finally, what will happen? This positive ion source will come out with very high energy. It will come out with very high energy. So this is the working of a cyclotron. So what is happening? Whenever the oscillator is activated, it will make one of the D's to positive and other D's to negative. The positive ion source will get attracted towards the negative region. Once it enters inside the D, what is there inside the D? There is a magnetic field. So whenever a charge is left inside a magnetic field, it will start to make a circular motion. Actually, it will make a helix motion, but here we are considering the particle is making a circular motion. Once it enters the D, its velocity increases such that its radius will also increase. Because what is the relation between radius and velocity? We know that R is equals to mv divided by qb. So here radius is directly proportional to what? Velocity of that particle. From where we got this equation? We know that F is equals to what? mv square by r. Whenever a particle is left inside a magnetic field, it will start to make a circular motion. This is nothing but F is, what is the force acting on that particle means? F is equals to mv square by r. This F is nothing but q into v into b. Charge into velocity of that particular charge inside a magnetic field. So from here we will be getting mv square by r. From here we are getting this formula. What is that formula? R is equals to mv by qb. So this is the end of the concepts for moving charges and magnetism. So in moving charges and magnetism, what are the things that we have discussed? We have discussed Biot-Savart law and its application. We have discussed Ampere's law and its application. Then we have discussed regarding the magnetic movement of revolving electron. Next thing we have discussed is cyclotron. So what is cyclotron? It is a device which is used to accelerate positively charged particles to high velocities. And what are the components of this cyclotron? These vacuum chamber, high frequency oscillator and source. I hope you understood this answer. Let us move on to the numericals of this chapter. There are 2 to 3 numericals. Once we are done with the numericals, these things will be enough for your moving charges and magnetism. Let me write down the numericals. Numericals from moving charges and magnetism. Numericals. Let us solve the first numerical here. So let me note down the question. See here. A current of, important numericals for your examination. A current of 10 amperes passes through 2 very long wires, 2 very long wires held parallel to each other, and separated by a distance of 1 meter, and see here what he is asking you to calculate: the force per unit length the force per unit length is So see here, this is very important question for your annual examination. If he is not asking any of the 5 questions that we have discussed, 5 or 6 questions that we have discussed, then definitely he is going to ask this problem. Very important problem for your annual examination. Very important question. Important problem. If he is not asking whatever the questions we have discussed, then definitely he will prefer this problem for your examination. So what is the first thing I said? That wherever you are getting the problem, first of all, write down the given things. What are the given quantities? Given. He has given a current of 10 amperes passes through 2 very long wires. So there are 2 long wires. Separated by how much distance? Separated by a distance of 1 meter. Separated by a distance of D is equals to how much? 1 meter. Through these two wires, how much amount of current is flowing? Through this wire, 10 amperes of current is flowing. Through this wire also, how much current is flowing? 10 amperes of current is flowing. I'm considering this one to be wire 1. I'm considering this one to be wire 2. No need of drawing the diagram in the examination. For explaining, I'm drawing the diagram. See here. How many wires are there? 2 wires. How they are held? They are held parallel to each other. And what is the distance between them? The distance between them is how much? 1 meter. The distance between them is 1 meter. And what he is asking you to calculate? He is asking you to calculate force per unit length. So what are the given quantities? Currents are given. What are the currents given? I1 current is equals to how much? 10 amperes. I2 current is equals to how much? 10 amperes. Both the wires are separated by distance how much? 1 meter. So these are the given things. Next, what you are supposed to write? You are supposed to write down the formula. Because for writing the formula also, you will be getting the marks. Formula. So what is the formula for this particular problem? Remember this formula. What is that? What is asking you to calculate? Force per unit length. Force per unit length is equals to, the formula is, please remember this formula, mu naught I1 into I2 divided by 2 pi d. This is the formula for force acting per unit length whenever there are two wires placed parallel to each other. Now let us substitute the values. I am substituting the values somewhere here. Just I will try to move this diagram so that I can solve the problem here. So I have moved the diagram somewhere here. Let us solve this problem. See here. Force per unit length is equals to, what is the value of mu naught? What is the value of mu naught? In the previous class we have discussed, maybe in the last video, in previous video we have discussed regarding mu naught. From here, what is that? dB into r square divided by IDL sin theta is equals to, what is the formula? Mu naught by 4 pi. So what is the value of mu naught? I said mu naught by 4 pi ki value kitni thi? What was the value of mu naught by 4 pi? It was 10 power minus 7 Henry. Or you can also write mu naught is equals to how much? 4 pi into 10 power minus 7. So remember this value. What is the value of mu naught? The value of mu naught is 4 pi into 10 power minus 7. Let us substitute that value here. What is the value of mu naught? I am taking the value of mu naught as 4 pi into 10 power minus 7 into, what is the value of I1? I1 ki value is 10 amperes. I2 ki value is also 10 amperes. So this will become what? 10 into 10 divided by 2 pi into d. What is the value of d here? 1 meter. So I'm writing 1 meter. This pi and this pi will get cancelled. 2 1s and 2 2s. So what will be our final answer? Our final answer will become force per unit length is equals to 2 into 10 power. How many zeros are here? 2 zeros. And here if I cancel the 2 zeros, how much it will become? It will become 5. So this will become 2 into 10 power minus 5. What is the unit of force? Unit of force is Newton. And what is the unit of length? The unit of length is meter. So by this we end this numerical. What is that? Force acting per unit length of two wires which are held parallel to each other. I hope you understood this problem. What is he saying? There is a current of 10 amperes which is passing through two very long wires held parallel to each other. There are the two wires which are held parallel to each other, and how much amount of current is flowing? 10 amperes amount of current is flowing, and they are separated by how much distance? 1 meter distance. And what he is asking you to calculate? He is asking you to calculate the force per unit length. And what is the formula for force per unit length? The formula for force per unit length is given as what? F by L is equals to mu naught I1 I2 divided by 2 pi d. So if you are substituting all this value, we are getting the final answer. I hope you understood this thing. Let us move on to the next numerical, next important numerical from this chapter. I hope everyone is doing this. See here. The next important numerical from this chapter is Second one, a long straight wire, a long straight wire, a long straight wire carries a current, of 35 amperes. Carries a current of how many amperes? 35 amperes. What is the magnitude? What is the magnitude? What is the magnitude of field B, at a 20 centimeter distance, at a 20 centimeter distance from the wire, See here, this is application. We have already did this. What was the question here? A long straight wire carries a current of 35 amperes. What is the magnitude of field B at 20 centimeter distance from the wire? See here, we have did this application. Where is that application? Here. He is telling that the distance from the wire is how much? Some 20 centimeter, and we are supposed to determine the magnetic field here. So what is the formula? B is equals to mu naught I divided by 2 pi r. So first of all, let us write down the given things. First of all, let us write down what? Given things. Answer. What are the given things? Given. How much current is flowing through the wire? A current of I is equals to 35 amperes is flowing. And what is the distance? The distance given is R is equals to 20 centimeter. So this is the arrangement for that. This is a current carrying wire. So we are supposed to determine the value of current for magnetic field at a distance of how much distance? R is equals to 20 centimeter distance. So current I, how much amount of current is flowing? I is equals to 35 amperes of current is flowing through this wire. So what is the formula we are supposed to use? What is the formula? The formula will become B is equals to mu naught I divided by 2 pi r. So if I substitute that value, what this will become? B is equals to, what is the value of mu naught? Just now we have discussed mu naught is equals to how much? 4 pi into 10 power minus 7. 4 pi into 10 power minus 7. So this will become 4 pi into 10 power minus 7 into how much amount of current is flowing? 35 amperes of current is flowing. 35 divided by 2 pi into r. R is equals to how much? 20 centimeter is given. So 1 centimeter is equals to how many meters? 10 power minus 2 meters. So this will become what? 20 into 10 power minus 2 meters. So if I substitute that value, what this will become? 20 into 10 power minus 2. So let us solve this. This pi and this pi is getting cancelled. This 2 ones and 2 twos. 2 ones and 2 tens. So what will be our final answer? B is equals to 35 into 10 power minus 7. If I take this minus 2 to numerator, it will become plus 2. If I take this 10 to numerator, it will become 10 power minus 1, isn't it? So here it will become power minus 1. So what will be our final answer? Our final answer will become B is equals to 35 into 10 power 2 minus 1 will become 1. 1 minus 7 will become what? Minus 6 Tesla. So Tesla is the unit for what? Tesla is the unit for magnetic field induction, or B. So this is our final answer. What is that? 35 into 10 power minus 6. I hope you understood this problem. So just now we have discussed two problems based on moving charges and magnetism. Out of these two problems, this is very much important, very important for your examination. So by this, we are done with moving charges and magnetism. So in tomorrow's class, we'll start another chapter, another FAQ chapter. Most probably we'll start atoms. If once we are done with atoms, we'll move on to ray optics. Once we are done with ray optics, we'll move on to wave optics. By that, we'll be finishing all the short answer type questions. Out of these 8 chapters, you study 6 chapters perfectly. Whatever the questions I have discussed, study those questions of 6 chapters perfectly and be perfect with the LAQs. Once we are done with the SAQs and LAQs, already LAQs we have finished the 2 chapters. If possible, before starting VSAQs, I will start LAQ wave. I will complete that waves LAQ chapter. Once we are done with that, we'll move on to very short answer type questions. Hopefully, by the end of the 10th June, we may be finishing the entire syllabus, which will be helpful for scoring 60 out of 60 marks for your examination. Whatever we have discussed till now, if you are able to read that, definitely you will be getting more than 60 to 70% of marks. Okay. So I hope you understood today's class. So what are the things that we have discussed in today's class? We have started with the formula for Biot-Savart law. This is which law? This is Biot-Savart law. And based on the Biot-Savart law, we have discussed one application. That is, application was what? B is equals to mu naught I divided by 2R. This was the application whenever a current was flowing in circular loop, the magnetic field at the center was given as B is equals to mu naught I by 2R. Then we have discussed Ampere's law. Of that Ampere's law, again we have discussed what? Application of that Ampere's law. Whenever a current is flowing through a straight wire, the magnetic field created at one particular distance R we have determined. And what is the answer we got? We got the answer as B is equals to mu naught I divided by 2R. Next, what we have discussed? We have discussed the magnetic moment of a revolving electron. As the electron is revolving around the nucleus, it constitutes some current. Due to that current, what will happen? Magnetic field will be created and it will have some magnetic dipole moment. So we are supposed to determine the magnetic dipole moment of that revolving electron. And what is the formula for the magnetic dipole moment of that electron? M is equals to NIA, where N represents what? Number of turns, I represent the current, A represents the area. So finally, we have determined the value of I, and we know that the area of a circular loop is given as pi r square, and we have substituted these values. Finally, we are getting what is the value we are getting? M is equals to EVR divided by 2. Then what we did? We have discussed another important concept from moving charges and magnetism. What was that concept? It was cyclotron. So what is the use of that cyclotron? Cyclotron is a device which is used to accelerate the positively charged particles. And what are the components of the cyclotron? It consists of a source, a high frequency oscillator, a vacuum chamber, and these. What this oscillator will be doing? Oscillator will be alternating the voltages. Sometimes it will be making the plate D2 as positive, and sometimes it is making the plate D2 as negative, such that due to the electric field, the charge will move towards D1 and D2, and such that inside the Ds, there will be a magnetic field, due to which it will make a circular motion. So as the velocity is increasing, radius will also increase. How do we know? We know that from this relation. What is that relation? R is equals to MV divided by QB. Next, what we have discussed? We have discussed two numericals. One numerical was based on the formula F by L is equals to mu naught I1 I2 by 2 pi D. And what was the other numerical that we have discussed? Other numerical we have discussed is regarding a straight current carrying conductor through which a current of 35 amperes is flowing, and we are supposed to determine the magnetic field at a distance of 20 centimeter from the current carrying conductor. So this all are the important concepts for short answer type questions from moving charges and magnetism. I hope you understood this class. We'll meet tomorrow. Thank you.